Hello, friend. Welcome to my YouTube channel, DevOps with Anil. Today, I am going to start new lecture series for Kubernetes. I have already completed my Docker series. Please have a look and then proceed with Kubernetes because it is a prerequisite for Kubernetes. So, today's topic is Kubernetes architecture. But before that, first we need to understand what is Kubernetes, why you should learn it. Kubernetes is an open source platform designed to manage containerized application. Container are a way to package application and their dependency so they can run anywhere on your laptop, on a server or in the cloud. But when you have lot of container to manage, things get complex. There that's where Kubernetes comes in the picture. So, what does Kubernetes actually do? Kubernetes helps you automate like tasks, deploying application, rolling back, roll out releases. Basically, when you want to upgrade or downgrade, you can do that at the time of deployment. Scaling up, down at the time of traffic, depend on the traffic. You can maintain the pod in such a way that when the traffic comes, your application is scaled dynamically and it's scaled down dynamically when the traffic is low. Also, handling failure. If something crashes, it restart automatically. So if your application is not responding, then it will be required a restart. No manual intervention is required. Kubernetes will do automatically. Basically, it makes sure your app is always up and running smoothly without you having manual intervention. Why learn Kubernetes? The next question is that many companies are using Kubernetes to run their app, so it is valuable skill in the job market. First thing, so it will affect you in the job market. If you have Kubernetes in your resume, it will impact you. Second, it automate a lot of work involved in managing and scaling apps. As a DevOps guy, if you are running application without any container orchestration tool, then you need to be on your toes. Suppose you are hitting traffic at the time of peak 5 to 7 p.m. That time you are consuming 4 VM servers and those are always running. But after the peak, those machines, 4 machines are not required. Only 2 machine can serve the your application. But you are running on VM, so it will be the problem. But Kubernetes helps you to scale up and down automatically. Means those type of tasks you can automate it without any manual intervention. At the time of configuration, you can decide whether how much required. At the time of traffic comes, it will increase dynamically and decrease dynamically when the traffic goes down. Most modern applications are moving to the cloud, and Kubernetes is the standard tool for managing them. So if you are moving to AWS, Azure, Google, all having their own flavor of Kubernetes structure. Means it's coming from the cloud native original one, open source one, but they have providing you this as a service to consume it, and they can manage their master node so that you can not worry about the master node. But your load will be running on their Kubernetes clusters. Generally, in the market scenario, in big industries, they are using their for AWS is AWS EKS, for Azure AKS, Azure Kubernetes Service, and GCP for Google Cloud. Before going to that, first we need to understand what are prerequisite to learn Kubernetes. That is important. So first thing is that you need to know basic terminal CLI command interact with Kubernetes. So you need to know how to interact basically CLI commands running on file managing, moving file from one directory to another directory. Those commands you should aware of it. Second understanding is requirement of container. So you can learn Docker. Docker. While watching my previous lecture series of Docker, I will add in tutorial playlist in my top right of the channel. Network basics. You need to learn basic networking. You should aware of that because Kubernetes required a lot of networking challenges, and you need to understand that networking concept like IP address port, DNS, load balancing. That will be helpful. Basic knowledge of YAML because we need to create a lot of YAML files for creating resource in Kubernetes. So basic knowledge of YAML is required. And last not the least, basic Linux command. Because I am going to install Kubernetes, I am going to make a video of installation of Kubernetes in a Ubuntu machine. So you need to aware of that basic Linux command. What are all those things? Okay. Let me start with the architecture. So Kubernetes is basically master slave architectures. So let me start and creating those from scratch. So suppose this is Kubernetes cluster. Okay. This is cluster, complete cluster we have here. Okay. In the cluster, we have two things, master and slave. Master, in the documentation you found it, control plane is also called, and slave they call as a node, but it is a similar master slave architecture where master can manage everything and slave can run the load actual application and pods are running on those slave node machine. So let me create here, these are the master component, and these are the slave component. Master slash control plane. And here this is a slave slash, let me put slave 1 and node 1, anything you can call it. So here master node is also a machine, slave is also a machine, and both are machines. So master we have one right now, but we can have a multiple master as well, and slave we can add it and remove it at any time. What are the number, it doesn't matter, we can add any number of slaves in the Kubernetes. So the main component of master node is, first one is it's called as Kube API server, and this will be the major main component, heart of the component, Kubernetes component, Kube API server. Everything interact with Kube API server. Even when you going to interact with Kubernetes cluster, this is the point of contact, Kube API server. No one can interact any other thing except Kube API server. Okay. Second is component is, it's called as ET etcd. What is etcd? It is basically, etcd is basically a database which store key value pair. So all the things, whatever happening on the Kubernetes inside the cluster, all the data is going to store in etcd only in the format of key value pair. And etcd can communicate only with Kube API server. It cannot interact with any other except Kube API server. So every communication comes from anywhere, it will come through Kube API server and then goes to etcd to save it. And for fetching the data also, it is going to be same. Etcd can give the data to Kube API server only. Now the third component is called as a scheduler. Scheduler. Oh, scheduler. So this component is mainly responsible to find you the resource and scheduling, find your resource for your application, which is proper resource, which node is available for you. The main task of this is schedule the pod or any service or resource where it can be scheduled, and basically find the available resource in the slave machines. So it is extract the everything from the details asked from the Kube API server. So it asks everything from the Kube API server. Kube API server check from the etcd and provide to them, and then it find the spaces on the nodes, and then this will provide the another component called as control plane. Controller managers, not control plane, sorry. Controller manager. Controller manager, Kube controller manager runs control processes. So logically, each controller is a separate process, but to reduce complexity, they are all compiled into a single binary and run in a single process. So what are the different type of controllers? There is a node controller. Suppose any node goes down, node goes want to join. Who is responsible? This controller manager. Job control. Basically, if you have watches for job object that represent one of tasks that create pod to run those tasks and completion, who is going to maintain that? This controller manager. And it's, yes, it is going to be communicate with Kube API server. So one thing, keep in mind, everything is going to communicate with Kube API server only. So these are the major component present in the master node. Master node can be the slave node as well, because you can create a pod and all over here as well. But generally in architecture or standard way is that master node should not be load any traffic, or any application should not be run on master node. So when I say slave node, what are inside in the slave nodes? So basically in the slave node there are two major things. What are the two things? First, let me copy this and paste and make it small. Kubelet. Kubelet is after the what the process is done. Kubelet, what is Kubelet? Kubelet is basically a binary which is responsible to run container inside the machine. So for running container, we need a container runtime engine in the each machine. So for that, let me create here one container. Container runtime engine. How I go this to, let me use this way. CRI. So this is a container engine running on the machine, and here any application or any pod is going to run. Who is going to responsible for that? Kubelet. Kubelet is going to run any pod inside the CRI, container runtime engine. So for that, I can mention here pods. I will explain the pod and all in the different lecture when we create those things. Pod is just, you can say, you can right now understand that it is a actual container running inside that resource. So that called as a pod. So let me run. Multiple pods can be run on the one one nodes will depend on the how much size of that node. So, and these pod, how define that which pod is running going to over here, that is the task of scheduler to find that what how much resource available on each node. And control panel will tell that scheduler is going to tell that Kube API server get tell information to control manager, and control manager will tell that Kube API server, yeah, we can go to that node. So Kubelet is going to communicate with Kube API server, and that is going to be basically tell them Kube API server, tell the Kubelet, now you can run this pod into your machine. So Kubelet is going to be start the pods. Okay. Now in one more thing present in nodes, what is that? That is Kube-Proxy. Kube-Proxy. What Kube-Proxy is responsible for that? Kube-Proxy is a network proxy that runs in each node in your cluster, implemented part of the Kubernetes service concept. So Kube-Proxy will provide you the network communicating between one node to another node, and another means this node to master node. Basically, these are two different machines. It is not running on same machines. This one is a different machine, master node. This one is a different machine. This one is a different physical machine. So need to communicate each another. So which is the responsible for that? Provide you the network is called Kube-Proxy is the one which is going to provide you. Kube-Proxy maintain network rules on node. It will maintain node wise. These network rules allow network communication to your pod from network session inside and outside your cluster. So if I copy this structure, so now we have same configuration over here. The pod of this pod and this pod are the same. All the 6 pod are same. So how load balancer will understand that which pod? So who is going to responsible for that? Kube-Proxy. Kube-Proxy is a daemon set which is running on each node, who is going to provide you the network visibility of each node, internal and external cluster. So this is all about the Kubernetes cluster architecture. You can find the same architecture in official document as well. So that's it for today's video. Next video I will going to explain you how to install Kubernetes of this one master and 2 slave machine on your local machine by using Vagrant tool. Okay, thank you for watching. If you like it, please hit the like button and subscribe my channel for more videos like this.